Okay, looks like we're online. So, hello everyone, and thank you for joining us. My name is Vladimir Litvinov, and I'm Java team lead at EPAM Systems. I will be moderating this session as always. We have a very special talk lined up for you today. First, we are inspired to welcome our first external speaker. It's Alex Filichkin, who is currently working as staff software engineer at Awin Global. Hello, Alex.
Hi guys. Hi everyone.
Thank you very much for taking time to lead the session. And I want to highlight that what makes this session even more special that Alex was the very first speaker in the first ever MGC talk. So in many ways, we're going back to where it all started. And Alex, once again, it's honor to have you with us here today.
Okay. Cool.
So today's topic is improving AWS Lambda startup performance with SnapStart. And let's see the presentation.
Okay. Can I start?
Yes, we can see it.
Okay.
Yes, and before we start, let me please highlight a few important things, if you don't mind. Let's switch to the next slide.
Yep.
So here's your profile, great. So as always, we will dedicate ample time for Q&A after the main part of the talk. So feel free to submit your questions to the chat or in the comments on the YouTube or in the VIA community platform. And one more, I don't know what is the marketing part, that if you would like to improve your skills in technical areas or even I don't know, enhance your abilities in teaching and mentoring. So please feel free to consider joining MGC School as a mentor or as a student. It's a really great opportunity to grow. To the next slide, please. And because Alex is here, so one more exciting update inspired by his participation today. We encourage all of you to join our community as speakers too. So if there is some topic you'd like to share with the world, reach out the MGC Talks by the email or using the QR code on the screen. We'd love to hear from you. And I believe that finally, without further ado, I'm excited to hand the session over to Alex. Take it away, Alex.
Yeah. Thank you, Vladimir. So one more time, thank you. Hi everyone. Thank you for joining. I hope this session will be really useful for you. And as you know, our topic is AWS Lambda and SnapStart. So today we will talk about SnapStart, but mostly from Java perspective. As Vladimir mentioned already, I'm a staff software engineer at Awin Global. It's like affiliate tech company, leader on the market. And I have a big experience in Java and AWS. And I also have a technical blog. I hope it will be very useful for you if you read it. I have mostly topics about Java, AWS, and some performance and comparison. Yeah, we already covered the slides. Yeah, let's go and see what the agenda is for today. So first of all, we start with brief introduction. What is AWS Lambda? Just to have some context. I know it's like annoying, but just a few words. Then we will try to implement some real Lambda function. And with plain Java, then we will try to figure out what the problem is, the first implementation, and we will try in a few iterations to improve our Lambda. And we will use also like SnapStart feature. We will check what is SnapStart, how to make it, what does it bring, etc. And at the end, we are going to make the performance in comparison and compare plain Java with SnapStart, with some special preparation with other different languages. Okay, let's go. Yes, so AWS Lambda. So AWS Lambda, I hope like nowadays everybody knows about it, but it's some function that can react on different events, like change data state event or API call or some SQS, some messaging or whatever. And this function can be written in different languages, different runtimes, like such as Node.js, Python, Java, Go, C# Ruby, custom runtime. These runtimes are ordered by popularity. So currently Node.js, Python, and Java are the most popular runtimes. And Java function, AWS Lambda function, should have some integration with different services, for example, with AWS services or even some on-prem services. Your Lambda can send some function to your backend. Yeah, actually, that's it. I hope everybody is already aware of it. Yeah, let's start with simple hello world example. In Java, like to implement Lambda function, you need to implement some interface, request handler. In our case, request handler interface some generic. And in our sample, we are going to handle API request call, API gateway call. So it's like REST-based Lambda, which can process different HTTP calls. So in our case, we just get the request, set status hungry to 200, and specify the body hello world. Pretty simple, like normal hello world example. And with 256 megabyte, so I would say the minimum memory setup what you need to use for Java, because with 128 megabyte you even will not be able to start the Java, because you will not be able to start Lambda. You will have out of memory exception, because Java requires a lot of memory to even for simple like function. But with 256 megabyte, you should target this setup for almost all your Lambdas. It's like more than enough for 99% of your load. Yes, and here I would like to highlight that when we run our Lambda, we have some like report, and in report we can see some important stuff. So we have like init duration time. In our case, it's 500 millisecond. Then we have duration. It's 109 milliseconds, and build duration. So duration and build duration it's almost equal. So you pay for build duration, but init duration you shouldn't pay for it. AWS doesn't count it. But your like function latency, if you send REST call to your backend, you should expect more than 600 milliseconds delay. Be careful. Do not rely on just duration. Always combine duration and init duration. And so in our case, we have 600 milliseconds processing time, response time for first invocation, which is pretty good. And yeah, very nice. Simple, fast, good. But let's talk about some like real use case, not about hello world example, but some real scenario. So I would say the most popular right now scenario is that you have some REST service that should save some data in data storage. So and DynamoDB is quite popular use case because it's like serverless. Lambda is serverless, DynamoDB is serverless. So it's very popular use case where our Lambda should have integration with DynamoDB. So in our example, we have the same like handler function, but here we have DynamoDB client. I prefer to use enhanced DynamoDB client. So it's some kind of ORM for DynamoDB. You don't work with plain like string, but you are working with objects. And in this case, you just create some client and object mapper, and in our function we just get the body from string. We make the object and we save this object and return some response back. So very simple use case. And let's check how it works. As you can see, we have init duration almost seconds, and build duration 6 and 5 seconds. So in total, we have 8.5 seconds for very trivial, like very simple call just to save some data in DynamoDB. Yeah, and why? Why it's so slow? Let's do some analysis. So first of all, to understand why it's so slow, let's analyze the AWS Lambda function lifetime. So function has two phases, like init. The first state is init. So when you create when you send request to your Lambda, Lambda still should have some like hardware to run your code. And AWS is using Firecracker, it's microVM technology. So it creates microVM. It's very efficient, fast. So in 5-10 milliseconds, you can create like isolated microVM. Then for Java, for example, you compile your code and you build your jar file and you upload to S3 bucket your jar file. And when Lambda is invoked, so it needs to download your jar file. Then it should start runtime. So for Java, it start Java virtual machine. And then it should make some initialization of your code. So like init function code, like static code initialization, class loading, and then the function is prepared. So and this state is like init. So you remember that we have init state, init duration. This is what happened in init duration. So we have 2 seconds for this init stuff. And then we have invoke. Invoke, it's like just go inside your handle method and run it. This is like first invocation of your Lambda. But when you send the second request to this particular instance of your Lambda, you will not have init phase anymore. You will have just invoke. So you run just handle method again. To prove it, you can enable X-ray, like AWS tracing tool, and you can see this like lifecycle in X-ray. So as you remember, we have initialization or init duration 2 seconds, and we have invocation 6 seconds. So this is like our lifecycle for cold start for the first Lambda invocation. But for the second invocation, we don't have any more initialization. We just have invocation. You see that in the second invocation is pretty fast, just 200 milliseconds. Yeah. So the second call is good. First one is 8.5 seconds. Yeah, and the main question, like, why do we have so slow first invocation and so fast the second invocation? We are not talking about the init duration when we need to create a microVM, download the jar file, a class loader should load all classes, etc. Yet it can take some time, but why invocation, just handle method, is so slow? Let's analyze it. Yes, so in our case, for our simple like Lambda, where we have only DynamoDB integration, our code contains, so class loader should load about 6,000 classes to initialize our function. So you can run some special like command to see all these classes. And class loader is really slow. Right? It should like load all classes, verify bytecode, they initialize some static stuff, and if you have so many classes, it really takes time. So the solution is use lightweight dependencies. For example, don't use SL4J normal, but use some specific simple SL4J, or not Jackson, but Jackson Junior. So like it's specially optimized libraries with some reduced functionality, but in most use cases you don't need such special stuff. The second problem is lazy loading. So many clients are lazy. It means so they will do some configuration or database connection only during the first invocation, and yeah, it's normal. Like it's best practice to have lazy loading, but for like serverless, for Lambda, it's bad. So to process it, you can do some dummy call in a static section to promote your lazy clients. So for example, you don't need to run this DynamoDB first call inside the handle method. You can do it before in static stuff. In this case, it will be like very big performance improvement. And for AWS also, if you have some integration with AWS services such as S3, DynamoDB, SQS, whatever, if you do not specify explicitly what region, what credential providers you're going to use, AWS is trying to solve it. And it sends like a few requests to metadata to understand what region is it, etc. My recommendation is explicitly specify this region, because during the deployment, you already know like where this Lambda will be deployed. So pass its environment variable, whatever. And yeah, usually the very popular problem is dependency injections. So if you have dependency injection and you're using like Spring Boot, for example, this Spring Boot makes this all beans injection in runtime, not during the build time, and it also like very slow. My recommendation: do not use dependency injection at all for Lambda. Lambda should be like very similar, and you don't need to have some like very complex DI. But if you still want to use it, use build time dependency injections like Dagger, Quarkus, and Micronaut. So it means during the compilation time, it will be your beans will be injected properly. Okay, and now let's talk about AWS Lambda SnapStart. So I just added some code from AWS documentation. It says this: AWS SnapStart for Java can improve performance up to 10 times with typically no changes to your function code. Yeah, so it looks very good. So no changes and 10 times faster startup. And our goal is to analyze and check if it's true or not. Okay, a few words about the SnapStart. So SnapStart is not so new. It was introduced almost 3 years ago, and it captures the initialization. How it works. So you have a function, and you can run some function. Maybe let's not talk about the function, but in general, you can have Java code. You can start your code, then pause it, stop on some like period of time, and then save this state in some secure storage. Save the state with heap with everything pre-initialized, and then you can resume from this state and proceed it. So like Lambda is using the same approach. So it just it runs your function, initialize it, then save in some cache, and then when you invoke your function, it doesn't do invocation from the beginning, it just resumes from the state. Like, very good approach. So it's available since Java 11, and it's like free for Java, only for Java. For .NET and Python, you have to pay additionally. Yeah, and there are 3 runtimes which are supported for SnapStart. It's Java, .NET, and Python. But we will focus on Java only for today. Yeah, as I mentioned before. So when you publish new function, your code should have like 2 phases, like deployment and invocation. So when you deploy your new function, so as we had before, our code is we download the core, start the micro-VM firecracker, start the runtime, load all functions, initialize the function code. Then we can do some snapshot hook, but it's optional. We will talk about this a bit later. And when in deployment, even it's deployed, then you can run this function. So during the deployment, you cannot communicate with this Lambda, but when it's deployed, when published, you can invoke this function, and invocation contains like restore snapshot and like optional phase post snapshot hook, and then invoke. So you just restore and execute your code. So we are just skipping a lot of steps, and restore and execution is just only 2 steps which are needed for SnapStart. And yes, and when you have the second invocation for this Lambda, you don't have restore anymore. You just have invoke, the same as we had before in normal plain Java implementation. The second call is just duration of your function like hand-on function. There is no any initialization. Okay, how to enable the SnapStart? It's like to enable SnapStart in console, you can go and just change one parameter. If you're using like Terraform, you can also just add one flag, like use SnapStart with published version. It's the only option right now, like published version. And actually, that's it. It's like one parameter. So let's enable it and check the performance. So let's see if we can achieve 10 times performance improvement without code changes. So I enable it, and let's see. So before we had some init duration, and build duration. Now we don't have init duration, we have restore duration. The restore duration in our case is 540 milliseconds. And duration in our case is 5 seconds, a bit more than 5 seconds. So now we have like 6 seconds. Before we had 8.5. Now we have 6 seconds. Yeah, but it's not 10 times performance improvement what AWS says, right? So really not what we expect. And I just want to confirm that if you enable in X-ray, you can see all these life cycle events. So we have like restore, it's fast, and invocation is slow. Yeah. So the reasonable question, how we can like reduce this invocation time? And the answer is snapshot hooks. So what is snapshot hooks? So we have ability to run some code before and after restore phase. So it means, so if you publish new Java function, new Lambda you publish, before like saving this function state in some cache, you also can do some, you can run some code. Not you, but you can add some code and it will be processed. And in this code, you can warm up all your clients, do whatever you want, like pre-initialize all lazy clients, do some magic. And then when you have invocation, you can like restore from this like already prepared clients. And Lambda, AWS Lambda use crack project. It stands for Coordinated Restore and Checkpoints. So it's not only for Java, not only for AWS Lambda, but in general, it's for Java. So crack was developed by Azul, as far as I remember, and it allows us to restore our function from some special checkpoints. So you can save some, you can have some checkpoint, save in this checkpoint, and then restore from this checkpoint. This is like proposed project for OpenJDK. It means it's not part of OpenJDK, and you need to add some dependency to include it. And now let's check what we can do to use this crack and SnapStart webhooks. To add it, you need to implement like some resource endpoint, resource interface. Resource interface, it's part of crack, so you just add like very small dependency for crack. And then if you have this interface, you need to implement two methods, like before checkpoint and after checkpoint. Before checkpoint and after restore. So before checkpoint will be invoked before saving this state to cache. So it means Lambda will be started, like virtual machine will be started, code will be downloaded, all function will be pre-initialized, and then this code will be invoked. So what we can do in this code? So my recommendation is this: in before checkpoint stuff, you need to initialize all lazy objects, like objects clients, because, for example, for DynamoDB table is like some SDK client, and if we have this user table save like update item in handle method, the first invocation takes like seconds, but the second invocation is fast because during the first invocation, DynamoDB table tries to resolve this region, create connection, etc. And so it's like lazy, and it will do all this initialization during the first invocation. So, and if we do this invocation inside this before checkpoint function, it will be already like prepared for the future use and will be stored in cache. So if you have Hibernate, if you have REST template, whatever, do some init call here, and then you can proceed in your handle function. You don't need to warm up it because almost all clients nowadays are lazy and you need to deal with it. The same for object mapper. So object mapper, to be honest, is very heavy object. And when you do some read value, serialize, deserialize objects, it's also very lazy. And without this improvement, you will have 500 milliseconds delay just for read value object. But the second invocation will be like very fast. So just to summarize, in before checkpoint function is the most important, and here we need to warm up as much as possible. Yeah, and after restore, to be honest, what I see, we almost never use it after restore method because this function will be invoked after, like, when we invoke the function will go to cache, will retrieve from the cache a snapshot, and then this function will be invoked. It's very difficult to imagine some scenario, but if you want to somehow change your cache or whatever before this processing, you can do it. You can do it here. But I don't see in my practice any use cases when we need to do something here. It should be empty. Sorry. And yeah, and we keep the same. So no changes in our main functionality. So we just do some warm up, some special optimization in our before checkpoint function. And then we run this function again. And now you can see restore duration. The same restore duration it was before. So before we had 500, now we have 600 milliseconds. This restore duration is not so stable. Usually it's about 400 milliseconds, maybe 800 milliseconds. So in average, it's 600 milliseconds. And I don't see any correlation between the size. So if you start Spring Boot application, we'll do this SnapStart, restore duration will be almost the same. So it means right now you can add as much as possible to your Java. Do not worry about the dependency size, whatever, because restore duration is almost stable and it doesn't correlate with this size of your jar file or like how many dependencies you have, whatever. Yeah, so we have 600 milliseconds duration, plus we have, restore duration, plus we have duration about half of second. And so before we had like 5 seconds here, now we have 400 milliseconds. So big improvement. This is what SnapStart can do. It can help you very much. So in general, great stuff. Our Lambda function with 256 megabytes with very small setup can be processed in almost 1 second. Okay, let's move on. Yeah, just want to confirm this for X-ray tracing. You can see invocation fast, restore. We cannot, just want to highlight this, restore duration we cannot improve. So if you add 10 gig of memory for your function or whatever, it will not solve. You will still have the same time. Yeah, some problem with restore. It's good, but potentially it can be maybe improved in future. So like 2 years ago, I tested restore duration time was almost 1 second. Now I see it's like 600 milliseconds, 700 milliseconds. There are some improvements. Hopefully we will see it in future. Yeah, and the warm start, so the second invocation for this function, it's normal Java function, so it's like fast. No problems here. So we don't have restore, just invocation. Okay, some snapshot considerations. So you have to be very careful with ephemeral data. So what it means? So for data that can be changed over the time, like password, secrets, some ID tokens, whatever. So if you do this, if you store in your function these passwords, secrets, it will be cached. And if you, for example, rotate your password and then you run your function, this rotation, password rotation won't be visible for your function because in cache we still have the old password. So be careful with it, and do not read password when or some values which can be changed. The second problem is network connection. So your code should be able to process different connection problem. So for example, if you have your function and in your function in pre-login or in before checkpoint method, you do some connection creation, right? So this function will be stored in cache, and you can use it for several years. But this connection we cannot keep this connection like ready, and this connection of course will be like dropped, and your function code should be able to process it. But to be honest, almost all SDKs, they can process retry connection without any problem. So like all AWS SDKs, like S3, DynamoDB, SQS, no problems at all. I tested for Spring Data, it also works. So I think like it's not a big problem, but just keep in mind. Yeah, one important limitation is that if you do not run your function for 2 weeks, your function will be inactive. And when you run when you send request to a Lambda will throw this SnapStart not ready exception. So the solution, how to solve it? If you have this exception, you need to redeploy your function. You need to deploy your function, save should be saved one more time, and then you can run it. So in our company, we prefer to use event bridge cron job that will invoke our function quite often, like every day. So we have here I mentioned 14 days, but we just have some fun. We have some cron jobs, some triggers, and this trigger will invoke our Lambda, and Lambda will be ready always. So it's not a big problem for production, because for production you mostly have some code always. But for example, for staging, for some development environment, you may have some cases when there are no events for 2 weeks and the function is down, they need to redeploy. Quite annoying stuff. So it means for every Lambda, try to add one more trigger, event bridge, and you can process gracefully in your functions. If it's event bridge event, just look, okay, this is warm up code, and ignore it. Okay. Yes, one important stuff that AWS SnapStart doesn't work with latest version. So it means that you cannot deploy your function and use it directly. You need to always use some version of this function or use aliases. So I recommend using aliases. For example, you can have alias like live, and when you deploy new function, when function is deployed, then you switch the version from you switch the alias from version previous version to this version, and now we have alias live. So it means all triggers should be pointed not to the latest version of Lambda, but to the alias. The same happens for provision concurrency. If you have provision concurrency, it also doesn't work with latest version. Why? So yeah, community already raised this question, why we have this limitation, and the answer was that if we always have latest version and AWS cannot understand what version is used right now, and it doesn't know when they can terminate the cache, because you always have latest and you need to keep all versions. Yeah, that's the problem. Okay, yeah, one more annoying stuff, that's if you enable SnapStart, your deployment will have additional one, usually maybe 2 minutes delay. So when you publish new version for SnapStart, this function will be in pending state. In this pending state, it usually takes a few minutes. So if you have alias, you just publish new version, and like new version in publish mode, it doesn't affect your production because you have some kind of blue-green deployment, and when function is published, only after that you can change the alias. But still keep in mind that it additional like deployment time. Yeah, why we have it? Because AWS start new function, then initialize this function, then save this status into cache, and it happens for all availability zones where you've selected. That's why it takes some time. Yes, and as I mentioned before, we cannot improve the restore duration time by increasing this memory setup, so it's always static. Yeah, and one more point, so most maybe not related to this topic, but if you use AWS Lambda layers, for example, very common use case, if you have some monitoring system like Datadog, or if you are using OpenTelemetry or whatever, usually they provide some useful Lambda layers. You just add some like credentials, and with no changes, your metrics logs will be sent from Lambda to some system. And if you have this, AWS SnapStart doesn't help with it. So SnapStart improves only your Java function, but doesn't work with layer. It's different different layer at all, so it cannot improve. So what I see is layers quite heavy objects, and try to do not use layers. And if you need, for example, to store the logs in some system, instead of layer, try to log your information to CloudWatch, and then have some asynchronous mechanism to move from CloudWatch to some Prometheus, whatever, to some like system. Okay, that's good. Alternative. Yeah, so we already mentioned that we have Java, it works slow, we can enable SnapStart with hooks, it works fast, but there is one alternative for Java, it's GraalVM, in particular GraalVM native. So with GraalVM native, you can compile your code into native code and have some binary file, and this binary file will be executed. So there is no initialization or whatever, it's just some like native execution that can be processed. Yeah, some good point is very fast, so it has like better startup than snapshot than AWS Lambda plus snapshot and SnapStart, because it doesn't read from state or whatever, it keeps everything. This also like memory footprint is better. With GraalVM you can start quite good Lambda. This with DynamoDB and Lambda you can start with the minimum setup with 100 megabyte. But not all libraries support it, and to be honest, it's very hard to maintain. I had some production like project with GraalVM, and GraalVM is native, has some special like clause word assumptions. There is no like reflection or runtime. You during the compilation, you should you should identify what function will be executed. So, and even in Spring Native, there are a lot of use cases where it works. Like this, for example, model works, but with Spring Native, there are some limitations. And I see for me, it's more limitations than benefits. So I don't like it. It's very difficult to support. Okay, and now let's compare our solution with other runtimes. So we have the same function to save some data in DynamoDB with Java, with GraalVM, SnapStart, and as expected, so languages like Java or .NET with virtual machine, it has much bigger response time, a cold start than compiled languages like Go or Rust. And as you can see, GraalVM still much faster than SnapStart, but the difference is not so big. And at least for us as Java developers, we quite okay right now with SnapStart. With very small changes, we can achieve quite good performance. But of course, if you don't have any restriction, you can use Golang as your main runtime and don't have any problem with cold start at all. Okay, some useful links. First of all, this reinvent session from Mark Sales. There are a lot of information how it's made internally, how cache works, etc. Very interesting stuff. Then there is my article about SnapStart, and also I added one interesting article about Spring Boot and Lambda. So with SnapStart, you can even you can use AWS Lambda plus Spring Boot with SnapStart. And for example, for 1 gig of memory, in our test we did 256 megabyte memory, but if you have 1 gig of memory for Lambda, and for Spring Boot, with Spring Boot and DynamoDB, so the same workflow to save some data in DynamoDB, you can achieve in 1 second, you can have this invocation, so cold start 1 second, you can expect for Spring Boot and SnapStart if you do all this priming or a snapshot hook properly. So very good results. So to be honest, right now, if you have Spring Boot application, you even can migrate it to AWS Lambda with minimum changes. I am not a big fan of it, but it's an option. Yes, that's it from my side. Thank you so much. I see that we have good time. Okay, and one more announcement. Vladimir, maybe you can help me here.
I thought we will start with questions and answers.
Okay. Yeah, let's start with the question.
Yeah.
Okay, Vladimir, do you have any questions?
We had one regarding the GraalVM, but you already covered it. And we have one question to summarize what you said. So Anton asking, in other words, you have used before snapshot event to warm up function, like initial lazy objects and so on. Then AWS snapshot do his job, make snapshot of already prepared memory Lambda, and then allow to reuse it. This way performance will be improved. Is it right?
Yeah. Yes. So if you have a snapshot hook and with SnapStart, performance will be improved. Yes.
Yeah. So just doing the initialization before usage. Yes. And saving the snapshot.
Explicitly run some method of your client. For example, if it's GPA, whatever, send just GET request. Give me some some data, or DynamoDB list all tables in a 3 bucket. Give me some metadata of this bucket, whatever. If you run some such command, your client will be initialized, and the next call, the real invocation, will be fast.
Great, thank you. So one question from me, you know that I like to challenge these new AI tools, and maybe we can try with you to take a look. Could, for example, ChatGPT solve the same situation? So we ask him to
Okay,
find a solution, and maybe you can be replaced already with it.
definitely will be. Okay, so let's ask how can we improve code start for AWS Lambda in Java, right?
Could you please maybe zoom the text because it's very small for me.
Uh, I don't know how.
Okay, we'll
Okay.
just read.
Okay. I hope it's better now.
Yeah,
Yes,
I
okay.
think so.
Okay. Yes. So let's see what ChatGPT advice. Yeah, optimize memory allocation. Yeah, you
Great
can.
advice. Yeah.
Yeah, first one by one. So optimize memory allocation, just add more memory. Yeah, of course it will help. But for example, initialization phase will not, if you add even 10 gig of memory, so 10 gig of maximum, initialization phase will not be improved because initialization phase already takes the maximum CPU. It has CPU burst time for first few seconds. AWS share all available CPU. So yes, it will help, but not so significantly. So even if you have 10 gig of memory for our first implementation, you will have maybe maximum 3 seconds. So still, and you will pay like 10 times
Yeah.
more if you increase more. Solution, but not ideal. Yeah, GraalVM native image, that's what we discussed, but I don't know why it mixed with SnapStart and ChatGPT as usual. So it's like some special dedicated topic. SnapStart is what we checked, but SnapStart leverage GraalVM to snapshot. No, it's not true. It's like SnapStart and GraalVM together. I don't see how it can work.
Regarding the first one, I believe that huge corporations paid that this option was the first one to just take more money.
I see. No, we have one more option, and if it's more popular, even one more option. Okay, so enable SnapStart for Java. Perfect. That's what we did. Minimize dependencies and reduce jar size. Jar size, I would say no. I don't see big correlation between jar size, but minimize dependencies, yes. So as less dependencies you have, as fast it will be started, because class loader shouldn't load these classes. So definitely like good approach, but it's in real world it's very difficult to optimize. If you start doing some some business logic, and then you need to think how to reduce it, you're trying to use some special libraries, it's very difficult. Yes, you can optimize some basic stuff like logging, maybe logging only. Yeah, you can have like some simple version of our logger, but in reality it's very difficult to, you cannot optimize it so significantly. Yes, I think this like use provision concurrency is the most popular solution for some big enterprises, but I really don't like it, because if you have Lambda, you have some serverless stuff. You have functions, Elastic. You have a few one request, you pay for one request. You have 1,000, you pay for 1,000. No request at all, you don't pay. With provision concurrency, you pay for time. So it's the same like start EC2 and process the request. So yeah, I don't like it. It's not scalable and expensive. Yes, some Java optimization. No, this is not an option, because AWS by default use AWS Careta, so you cannot change the runtime. You can do it with custom runtime, but it's very tricky and doesn't bring a lot of value. Yes, this option works definitely. Before SnapStart, I did such optimization. What is it? So in Java, as you may know, we have tire compilation. We have like C1, C2. If you, for example, you have your service, and as you may notice that the first, I don't know, 10,000 requests is not so fast. So to save some data, it takes, I don't know, like 100 milliseconds. But later, in 1 hour, it works much better. And it happens because after like 10 invocation, Java, 10,000 invocation, I believe it's default value, Java can make some optimization and change, like not optimize, optimize bytecode. But the most significant change is that it can use native code instead of your bytecode. So it has profiler, understand what is the most hot passes, and optimize your code. Yeah, and it's not applicable for AWS Lambda, because usually your Lambda will not be invoked 10,000 times, because you invoke Lambda several times, and then Lambda can be like terminated. And when you run this operation, run your Lambda with such options, you will just ignore these big optimizations, because big optimization is good for long-lived processes, like, for example, Docker-based services. For Lambda, it's not. Yeah, you will achieve some improvement, not significant, but like 20% you can improve. Yeah, avoid reflection, heavy frameworks. We already considered it, so yep. Choose a faster Java framework. So you know that we didn't use any frameworks, but we have 8 seconds delay. So it's not an option. And keep your Lambda function warm. Yeah, it's anti-pattern. So because if you do not know how many functions you need, how can you keep all this warm? So, and even AWS doesn't guarantee if you invoke the function every 1 minute, that function like will be alive. Not an option. Optimization code, yes. And use AWS Lambda extensions. I don't agree with it, or maybe I never used it properly. How Lambda execution allow? No, I don't think that's true. So yeah, we see that a few options. Some recommendations are good, but some are a bit confusing.
So we still need engineers with
Yeah.
a great background. Yeah, sounds great. Okay, one more, I believe, short question. So why do I have to choose Java in Lambda instead of other programming languages?
Yeah, why?
Why?
As we discussed before, if you want to have like good performance without any optimization, for example, if you have Go, you run your function without any special hooks, tunings, whatever, you will have good result, because you compile your code in native code and you run it. And for example, with Go, you can run your function with a minimum memory, 100 megabyte, and for almost all use cases, it will be more than enough. For Java, you need more memory, you need some special tunings. But yes, but sometimes you have already a big piece of code in Java, and you have Java teams. And Java is really good for like Docker-based services, and you don't want to have one more runtime, one more language. It's additional complexity for your company, for your organization. That's why you can use Java.
Okay, thank you. So I think that's it. So let's move on to my slide and wrap this presentation. Okay, so guys, first, before I would like to say that, let me remind you that if you enjoyed this event, please feel free to thank our speaker by using the community link. You can find thank you button there, and it's really great to feel that your work is appreciated. And second, let's talk about next event. So we'll talk about learning of algorithms why do we need it, and easy, medium, and hard answers. We don't have a starting date yet, but it will be announced a bit later, so stay tuned for updates. And I believe that's it. Thank you once again for joining us, and have a great evening. Goodbye.
Thank you, folks. Goodbye.